Oh, sorry, there's a problem. So that's why my voice is okay. So I will start from again, start from the first. Now, this is the loop we have used. So let's say this loop is used. This loop we have used for what? This loop we have used for finding the minimum cost edge from the cost adjacency matrix. So minimum cost edge matrix, we have used that. After that, we are saying that A equal to U, we are declaring this as the coordinate and V equal to another coordinate. So then we will find U equal to find U. This is what, if you remember, this is used for finding the our parent of the I, that this find method which we used to finding the parent. Now here as a parameter we are passing u, that means u and v, this will be two coordinates and between them the cost. So u and v, if you remember, we find like that, u and v, these are, and between them the edges are present, we will find the edge of this. So find method is what? Find method, find u. First we will find that this vertices parent, and same as that, likewise we will find the v, means this vertices parent, we will find like that. So this is what this find functions will do, and after this find functions we find the parent and the edges will be printed. The edges we will print into it. Now the edges which we will print, that's why we will write %dh, and that is edge %d is a comma, to use a comma here. So now this will do what? This will print that the edge from u and v, that this between these two edges, what is the minimum? It will print here. The edges will be printed. So /n and ne plus then a, then b, and the minimum. So this minimum will do what? This minimum will, the minimum value of the whole graph, it will print here, the minimum value. That is the minimum value of the whole, from the whole graph. What is the value of the minimum cost of the root? It will print that. And this min cost functions, which is minimum cost, that is equal to, this should be same, minimum. Okay. Now after that, the if functions is completed. Now if after completing the if function, we, that is cost of a comma b, cost of a comma b equal to, we are saying cost of a comma b, that is equal to cost of b comma a equal to 999. Okay. So why I write this? That means if this is written why? This is written because if the graph is non-directed graph. Now this is written, let's say inside I have write for your preference that it is written because if it is non-directed graph, and if the non-directed graph and if it is non-directed graph and if the non-directed graph diagonal is checked, then the graph is reflected. This is why we have used like that cost AB equal to cost of, that's why we have used cost of AB equal to cost of BA equal to 999, because it is, if it is a non-directed graph, then then the diagonal will be checked, and if the diagonal is checked, then the graph will be reflected. But this condition, if if it is of the directed graph, if we use the directed graph, then this condition became false. This condition became false if this condition will not be executed. But if it is the non-directed graph, any direction is not given, then only these conditions will be reflected. Okay, so this is what we have done. Now after that we will find the minimum cost. Now let's say we'll find the minimum cost. So it will find the minimum cost, means total minimum cost. We will find that is printf, let's say t, then minimum cost equal to %d / n min cost, and it will return 0 because we have used int main, so it will return 0. Okay, so we have written the program. So let's first compile it. We will write the name as algorithm Kruskal dot com. Algorithm Kruskal dot cpp. Now it is compiling. Okay, first statement. Okay, so there is saying that enter the number of vertices. So let's say we have taken the number of vertices. Let's say number of vertices we taken as the 6. Now we have to enter the cost agency matrix. So we have taken that the number of vertices as the n. So now we have to put the cost agency matrix. We have to put the cost agency matrix. So we have used 6 vertices. So that means there will be total 6 into 6. That means 36 values should be used here. So let's say we're using 0, 3, then 1, then 6, then 0, then 0. That will be the cost agency matrix. So if the cost agency matrix in sidewise, I am creating like this. So we have used 6 vertices. We have, if we have used 6 vertices. So 1, 2, 3, 4, 5, and 6. Same as that from here. 1, 2, 3, 4, 5, 6. Like this. So in first, what we have done, in first we have put 0, 3. So 1 to 1, 0. That means no self loop present. Then 3, then 1, then 6, then 0, then 0. This is the values I have put till now. Then after that 3, 0, 5, 3, 0, 5, 0, 3, 0. Let's say I have taken that. Then 1, 5, 0, 5, 6, 4. After that 6, then 0, then 5, then 0, then 0, then 2, then 0, 3, 6, 0, 0, 6, and 0, 0, 4, 2, 6, 0. So that means the cost agency matrix here, it is 3, then 0, then 5, then 0, then 3, then 0. Next is 1, 5, 0, 5, 6, 4, then 0. Sorry, from this is done from 6, 6, 0, 5, 0, 0, 2, then 0, 3, 6, 0, 0, 6, and then it is 0, it is 0, it is 4, it is 2, it is 6, it is 0. So that's how it is prepared like that, the cost agency matrix. So where there is 0, that means 1 to 1 it is 0, means there is no self loop present. 1 to 5 there is 0, means there is no connection, there is no edges, no edges are present to 1 to 5. From 1 to 6 there is also no edges. Like that we have prepared the cost agency matrix. Now among them, what is the smallest? First, choose the minimum cost edge. First, choose the minimum cost edge. So according to it, if we first look, that means if we, let's say, here, if we enter it, you see, sorry. One minute. The values that I'm able to take. Okay, 1 minute. Six, seven, two, zero, four, two, six. Yes. Now it is there is some small mistake that in that case the mistakes happened. So that's why in that time it is showing all zeros. In that time it is showing all zeros. For this reason, the changes is here for I have assigned 0 here. So it is not like that. So that's why the problem happens. Now, if we see, this is the cost agency matrix we have entered. This is the total cost agency matrix. This is the cost agency matrix. So according to this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So total 6. Same as here also it will be present 1, 2, 3, this is 4, this is 5, and this is 6. Now, if we check the minimum first, what is the Kruskal algorithm property? The Kruskal algorithm property is to find the minimum cost edge. So if we see in the first, the minimum cost edge, the minimum edge we find is what? This is the minimum cost edge 1. So it is of what? 1 and 3. So that's why you see the edge 1 and 3 it is written. First edge. So that means 1 and 3, this is chosen. Now 1 and 3, the graph is made and it cost is 1. The next we see the next we will see is the 6 to 4. 6 to 4. Yes. 6 to 4, it is the value is 2 here. The value is 2. So that means 6 to 4, another edge, the next minimum edge. The next minimum edge is chosen 6 to 4. The next minimum edge, it is chosen 6 to 4. So it is value is 2. Then the next minimum is the value is 3. So the value 3 first came from 1 to 2 edge. So 1 to 2 edge, we choose it, the 3 value we have chosen. The next minimum is our, we are here, it is taken the 2 to 5. The next minimum is this value, this chosen. You can also be able to, this is value is chosen as the next minimum, 2 to 5. So 2 to 5 is chosen the next minimum, and 6 to 3 is chosen as the next minimum because its value is 4. Now this cannot be chosen because if we choose here, then it will form a cycle. So this value cannot be chosen. This value cannot be chosen here. Same as that, like this way, we find the minimum cost spanning tree. And if we add this all, the cost we will get is total 30. So that's how the Kruskal algorithm works. So this is the programming of the Kruskal. Okay, clear to everyone? It is clear?
Yes, sir.
Yes, sir.
Okay. So then you do this program, run into your machine. I am 1 minute. I am use it as a full screen. Then it will be easy for you. Full screen mode. I will use it in the full screen mode. Okay. So if we use this in the full screen mode, then it will be easy for you to see the total programming. And after that, you can run. Okay. So I am giving you time. I am here. So if any problem happens, ask me in that time. And in this meantime, you run this program. Okay. So everyone run this program. And if anything, any problem happens, ask me. I am already here. And you do this program now. Okay, so everyone completed this? Everyone completed this? Everyone? Do you completed the program?
Yes, sir.
Yes.
Okay,
Yes, sir.
so then so then I am giving the options, sharing options. So one by one, you share the screen. So first, Abhishek. Abhishek. Abhishek Kumar Verma. Abhishek, can you hear me? Okay, let's then Abhishek is not able. So next I will call Tania.
Yes, sir.
हाँ, तो तुम शेयर कर सकते हो तानिया.
Yes, sir.
अच्छा, तो
Sir, here occurring some minimum cost is not minimum value is
Yes,
not
yes, yes.
written, sir.
Minimum cost. Then one time you open the code, please open the code so I can able to see that what is happen. Open the code. Okay.
Sir, is it
Cost.
visible?
Screen is visible. Screen is visible. Okay, go first. Start from top. Start from top. Okay. Include maybe minimum cost. Find does it. Retention. Then enter the cost urgency matrix. Fine. Okay. This is available in cost entry. Okay, go down. Go down. Okay. Tanya, go down. नीचे 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 लेके आओ थोड़ा.
Yes, sir. Yes, sir. थोड़ा नेटवर्क इशू हो रहा है सर, नीचे शो नहीं कर रहा.
देखिए. अच्छा, नीचे आओ थोड़ा. आओ नीचे आओ नीचे आओ. ठीक है. और थोड़ा नीचे आओ. Main have.
सर
हाँ आदित्य
यस
तुम्हारा
सर
देखेंगे हम।
सर while लूप के नीचे जो सर